Hello friends, welcome to Greedy By. I am Arham Doshi and let's get started. In this video, we'll be discussing about comparators. And what are comparators? Comparators are basically the functions which decides the order of sorting. In this video, we'll be discussing about default comparators, inbuilt comparators, how we can use our own comparator, that is custom comparators, and in user defined struct how we can define comparator. Okay, after that I will be showing a trick that we can use with pairs, in which we won't be using any comparator. We can simply use this trick to solve problem. Okay, and after that we will be solving one problem that will be, in that we will be using custom comparators. Okay, so let's go. So let's say we want to sort this array, and to sort this we can use the sort function that we discussed earlier, and it will use three arguments, that is the starting of the array, ending of the array, and one more optional argument is comparator. Okay, so at first we will try to run without it, and we can see this array is sorted. So there is an argument cmp here, but if we are not giving it, it will take by default argument of the data type it is using. Okay, so int, so if we are using int, it will automatically take the argument like this. So this is nothing but comparison function that it is taking automatically of int, and this is an inbuilt function. So even if we are giving this comparator, the output is not changing. Okay, so after that we come to know about another thing is inbuilt comparator. So there are some functions that are inbuilt into C++ language that can be used while sorting to change the order. First is less, another thing is greater. If we write greater n, it will automatically sort it into descending order. So now we'll discuss what is comparator. Okay, so what is this function and how it is used to sort the array. So if I write my own function of sorting, let's write a simple bubble sort. So after this we can see the array is sorted. So in this, what this condition shows is a comparison function. This is basically comparison function, and if we change this condition, the output of the array, the function will change. So let's do so. What we can do is we can just extract the logic of this comparison function in and take it into another function. Let's define a function cmp here, and it is taking an argument like two arguments, and it will compare both the elements and return what should be on the left side. So if a should be on the left side, it will return true, and if b should be on the left side, it will return false. So we will just return if a is less than b. Okay, so if a is less than b, we should not change, and if it is false, then we should change. So we are just giving our arguments to this, and if this function is false, we will just swap the array, swap the elements. Okay, now let's take the case of pair of integer. We will be we want to sort all the pairs of integer on the basis of first element, and if the first elements are equal, then we'll be sorting it on the basis of second element. Okay, so there is a by default comparison function which will do this. Okay, so if we write something like this. We are taking the input, we are sorting it, and we are just getting an output. Okay, in this case we can see that it has first sorted on the basis of first element. Then if the first element is equal, it is sorted on the basis of second element. So what if we want to sort it in decreasing order? So we can just write uh, greater inbuilt function for this, and it will sort basis on this. So now when talking about custom comparator, so now what we want to do is we want to sort on the basis of ascending order with respect to first element, but if the first element is equal, then we want to sort on the basis of second element on descending order. So for that there is no inbuilt function, so in this case we have to write our own comparison function. So it has something syntax like that. It will take two arguments, 1 and 2. If the first element of the pair are different, then we want the smaller element to the right side. Okay, so if they are both are not equal, then we will return true if the smaller element is on the right side. Okay, so and if the first element is equal, then we will sort the according to second element on decreasing order. So in this case we will just reverse the condition. Here we need to return it, and we see the results. If 2 is equal, then it is sorting on the decreasing order of the another element. Okay, let's say we have a struct P, and it is having three things, x, y, and z, and by default there is no comparison operator for struct. So in this case what we have to do is we have to overload the operation less than for the struct. Okay, and we will give input another struct that we want to compare it with the current struct. Don't forget to write const here, otherwise it will give error. In my computer it was giving error. Okay, so we'll just compare all the three elements. We'll first compare on the basis of x, then we'll compare on the basis of y, and at last if both x and y are equal, then we'll compare on the basis of z. So if x is not equal to p dot x, return the comparison between the two. Similarly we'll do it for y and z. So now what we are doing is we are declaring the vector of struct, we are just taking input, we are sorting, and in this sorting it will automatically take this operand as a comparison operator, that is less than operand. It will first check whether the x values of both the elements are equal, not other if they are not equal, then it will sort it based on the first element. Otherwise it will sort it based on, it will see if second element is not equal, then it will sort it based on second element. If both first and second uh, x and y is equal, then it will look for z and it will sort it based on the third element. Okay, and we are just then printing it. Okay, so we can see that it is sorted first on the basis of this. If they are equal, then it will look to this, and if they are also equal, then it will look to this. Okay, what if we want another type of operator? We can also do is we can like, if we want to do something like that, first sort it based on first element, then sort is based on the sum of other two elements, then we can do it like this. Let's take this example. Here the second element is smaller, but the sum of second and third element is bigger than the sum of these two elements. Okay, so it should be lower here, see. Okay, so this was all about the operator overloading. Now let's move on to the trick that I wanted to say. So the trick was basically when we are using the pair data structure. So let's say we want to sort based on first element in decreasing order. So what we can do is we can just take that and multiply it by -1, and when we are printing we can again multiply it by minus, and it will so it is like first pause. Okay, so in this we can see that without any comparison operator we are getting amazing results. So you can also do it with integer if you want to sort it in decreasing order. So if you want now to sort second element uh, by decreasing order, you can just multiply minus here, and it will like, if both the elements are equal, like let's say first one is equal here, then it has sorted based on second element in decreasing order. So that was small trick. So using this trick you can simulate lot of things without any custom comparators also. So now let's move on to the question. The question is like this: you are given n points in a 2D coordinate planes, and you are given an array of points with point of I is equal to xi comma yi, that is a vector where the first element of the vector denotes x coordinate and second element denotes y coordinate, and you need to return the k closest pair to the origin. So what we can do is we can simply sort the array of points using our custom comparator, and we will write the comparator here, and comparator would be like this. So what we will just compare the distance. So distance of a is like a of 0 into a of 0, like that this is basically just uh, Euclidean distance, and we can just return the smaller element first, like this. So if the first element is smaller than second element, we will return true and we won't make the swap, and if the first element is bigger, then we will return false and it will just swap it. So after that we can just take the answer is basically first k elements after sorting. So you can see how easy this question has become after using a custom comparator. And until next time, bye guys.